Hello everybody. Welcome to our long paper, The Archives Unleashed Project, Technology, Process, and Community to Improve Scholarly Access to Web Archives. My name is Milligan, and I'm presenting on behalf of our broader team, which includes Nick Ruest, the lead author from York University Libraries, Jimmy Lin from Computer Science at the University of Waterloo, myself and Samantha Fritz, both from the Department of History at the University of Waterloo. By way of introduction, my name is Milligan. I'm the principal investigator of the Archives Unleashed project, and I'm an associate professor of history at the University of Waterloo. Now that's a good segue, because one of the questions that you might be thinking is, why is our historian speaking to you here at JCDL? Well, since 1996, there's been a conscious effort to ensure the preservation of born digital data through web archiving. Web archives are essential to studying post-1990s topics and act as an access point for exploring our modern historical record. But there's a lot of challenges to using web archives. The abundance of born digital data is overwhelming, scholars are ill-equipped to face the deluge of digital materials for study, and how to provide scholarly access remains, to say the least, a challenge. Well, this is where the Archives Unleashed project comes in. Our goal is to improve scholarly access to web archives, and we do so by focusing on three main stakeholders that are all sort of germane to the JCDL community. First, we focus on librarians and archivists, gathering those who gather and manage digital collections. Computer scientists, those who build tools necessary to manipulate digital collections, and of course scholars, historians, the like, who are interrogating contents to support various lines of scholarly inquiry. But trying to provide scholarly access to web archives brings us to a bit of a chicken and egg problem. Without guidance from users, tool builders lack an understanding of what scholars might need. But without existing tools as reference points to understand what's possible, it is difficult for scholars to articulate their needs. And so we think the Archives Unleashed project has a solution here. We've adopted a simultaneously and mutually reinforcing three-pronged strategy: tool creation, combined with process modeling, combined with community building. And I'll explain how this works in this paper. Our project has a fairly long history. To understand where the Archives Unleashed project has come from, we can go back to 2014 with the Work-Based project. This was led by Jimmy Lin, who was then at the University of Maryland. It was a forerunner to what we'll later call the Archives Unleashed TOOLKIT, and crucially was a scalable web archiving platform. But it suffered from the problem of a tool builder without users. Luckily, in 2014, Jimmy Lin and myself met with some other individuals at a Harvard workshop, the Working with Internet Archives for Research workshop, and we began brainstorming how could we actually make this happen. And so our first solution was to run what we have here as the pre-Mellon Datathon series. We decided to have in-person events that would bring researchers and tool builders together to try to build community. The model worked. We recognized that scholars were facing barriers to working with web archives, and that there was a need for better analytics tools, community infrastructure, and accessible web archival interfaces. In 2017, we received funding from the Andrew W. Mellon Foundation to produce the Archives Unleashed project, and over the last 3 years, we've been working on three things: the Archives Unleashed Toolkit, the Archives Unleashed Cloud, and the Archives Unleashed Datathons, and we'll talk a little bit about these in this paper. So, what are we doing with these? Well, the first major deliverable was the development of the Archives Unleashed Toolkit. It's an open source platform for analyzing ARC and WARC files, which are the web archive container file formats. It represents the evolution of the work-based platform and is informed by a better understanding of a scholar's needs. And I'll go into detail on the toolkit shortly. The second was to deploy something we call the Archives Unleashed Cloud, which would be a one-stop web-based portal for web archive analysis. The goal here was that the cloud would provide access to the toolkit. You wouldn't need to manage the toolkit infrastructure yourself, which is like running Apache Spark on your own system. It would bridge the gap between open source tools, which are powerful but hard to use, and deployment at scale. It would let archivist users ingest their collections, and crucially would operationalize something we call the FEAV process model, discussed in our paper, which I'll explain a little bit more shortly. And then finally, we wanted to organize the Archives Unleashed Datathons. These would continue those earlier in-person events to build out and engage with community, would focus on tools and services developed by the project, and it had the long-term goal of developing sustainable scholarly community around web archiving that extended beyond the life of the project. So what were the high-level lessons we've learned through these last 3 years with the Archives Unleashed project? Well, crucially, the first important thing is the development of something we call the FEAV process model, or the filter, extract, aggregate, visualize process model. And that's because we realize that the process of scholarly inquiry is the most critical component in building and sustaining a community around web archiving. Now, this process model we've developed provides a descriptive characterization of scholarly activity, offers an organizing framework for the project, guiding development, and provides reference for scholars to consult. The main insights we have is that the activities of the model can be disaggregated across time, space, and tools, and the derivative products provide useful starting points to scholarly inquiry. Now, to develop the process model, we really have to go back to those early datathons, where we realized that scholars were often unsure of where to begin when they wanted to analyze their own collections. And so we started out by establishing a cookbook, which had a series of recipes for addressing common analytical tasks that scholars wanted to do. And by doing so, we began to see a common process emerging across these scholarly questions, which we then developed into a process model. And you can see this figure here from our paper at right. And basically, the FEAV model then takes you through 4 steps. And the first we realized is that scholars always begin by filtering, to take a lot of content, hundreds of gigabytes of a web archive, terabytes, and reduce it to a manageable size. This would be focusing on a particular subset of a web archive. And you could subset the web archive in 3 main ways. You could do it through context, based on the text or the hyperlink structures between pages, such as pages that mention only particular keywords, or pages that link only to a particular website or domain. Websites that say climate change or link to the United Nations. Through metadata, the crawl dates found in the work header, we only want web pages from 2014, even though the collection spans a decade, or pages that match a specific URL pattern. Or other extracted information by using user-defined functions. I just want the PDFs. I just want the images. I just want the videos. I just want the PowerPoints for my PowerPoint karaoke party. And crucially, when we're filtering, all of that can be arbitrarily complex and nested. So a scholar begins by filtering, then they extract. They extract the information of interest. That's also done through user-defined functions, or UDFs, and we provide a library of dozens of UDFs to perform these common operations. So you might take a web archive and say, I want the extracted plain text from raw HTML documents, but get rid of the tags. I want to find named entities. I want to see the sentiment of the text. I want to take information. I just want to have PDFs. I want to have other things. And we could actually even take the images and begin to work with them as well. So we filter, we extract, then we aggregate. We filter, we get records of interest, and then we need to summarize them for human consumption. Okay, we found the hyperlinks. How many times is this page linked to? Okay, we've done named entity extraction. How many times is this individual mentioned? And then finally, we visualize, the V of the model, where we present the results in a visualization. It can support further exploration. It can be prepared for publication and consumption. And the goal here was not to create our own visualization toolkits, but to provide interconnections with other visualization toolkits. So we might produce tables, or in the case of networks, produce it in a format that can be natively read by the open source network platform Gephi. Now, as part of this FEAV cycle, we also realized that really scholars would ask these questions. They would filter, they would extract, they would aggregate, they would visualize, and would often come down to sort of 3 main things that scholars were always extracting and working with in varying degrees. And so the first was the domain distribution. Scholars wanted to know what was in a collection, what domains and URLs have been captured, and what dates were collected along with those. They want the web graph. What are all the domain to domains that have linked to each other? What are the influential nodes in a web archive? What are the ones that people didn't link to within that collection at all? And of course they want text. We love text. People want to take the plain text from all the web archives. They can set up their search engines. They want the metadata that was found in the header or in the HTML itself. All of that can support rich scholarly questions. Now we realized the FEAV cycle then, firstly, through the Archives Unleashed toolkit, which I've mentioned before. So it was a success for Workbase, and crucially, the Archives Unleashed toolkit provides a domain-specific language for analyzing web archives built on top of the open source Apache Spark data processing platform. And it's a best practiced open source software thing. You can check us out on GitHub. It has three main capabilities. It can take work and the earlier ARC files as input, and it can output to other external applications such as Gephi. It provides a library of user-defined functions, or UDFs, for extraction, and it is built around convenience transformations where we can reduce the verbosity of analysis scripts. Now, there are two main developments that we've been able to bring to fruition over the course of the grant. The first main development is that we've achieved parity support for data frames alongside resilient distributed datasets, or RDDs. Moving towards data frames lets us organize data into named columns, flattens the learning curve and lowers barriers to adoption, and crucially allows the Spark engine to make certain optimizations that would not be possible with RDDs. The second main development has been achieving parity between Scala and Python. Apache Spark's native language is Scala, but digital humanists and other researchers wanted to use Python. So we thought by adopting Python we could further reduce barriers to adoption, we could use the more widely adopted Python language, and crucially we could use PySpark to have a Python interface to Spark. And we're happy to announce that we've been able to replicate in Python all of the existing functionalities of Scala. So that's the toolkit, and then we have the cloud. Now, the cloud is the canonical development of the toolkit. It's also open source and publicly available. The cloud portal allows one to ingest collections and leverage the capabilities of OT, and it has tight integration with the Internet Archive's Archive-It service. We decided to develop the cloud because we realized that installing, configuring, and deploying an Apache Spark-based toolkit was too much of a barrier of entry for lots of scholars. And so now a user can come to the Archives Unleashed cloud, go to cloud.archivesunleashed.org, authenticate with their GitHub or Twitter credentials, see a dashboard to see an overview of their collections, import metadata from Archive-It, use the Internet Archive and others, the Wasapi data transfer API standard to copy the raw works and ARCs to our storage, and coordinate the generation of standard derivatives. Once the collections are synced, you can then analyze them. You can play with hyperlinks in that diagram, you can see what's in that collection itself through a graph, and then crucially you can use those download links at the bottom to download derivative products, the full text of a collection, the top 10 domain full text of a collection, the Gephi, the domains, and other sorts of information. To date, we've been really successful. We've analyzed almost 912 terabytes of unique data between 235 users. We've analyzed almost 1,400 collections, and we've produced over 6,500 jobs. And all those numbers are a little bit higher when you're listening to this talk right now. We also finally created some notebook prototypes. The idea here was to further lower barriers to entry. The idea here was to connect derivative products to notebooks, which are a popular tool for data science. You run them in your browser, you run code fragments, you can read descriptive prose, you can execute your results. We can host them in the cloud with Google Colab, so there's minimum setup. And we actually right now, and I'll highlight this really quickly, have a workflow where you take collection derivatives that are hosted in a cloud service such as Zenodo and pre-populate your notebook with example analysis. So we can see here we've loaded a collection. This is from the Quebec National Archives. Loaded up a collection, and the Quebec National Library. Load up a collection, and we can see this analysis. And we can actually see this here. There's a collection in Zenodo. A collecting institution can publish their derivatives to Zenodo or Dataverse, and then you can actually load this in and just drop that DOI into the notebook, and suddenly you're actually working with that collection right away. So what's the road ahead? We've really identified two distinct user types. The majority of users are consuming derivatives with the toolkit or a tool of their choice, whether that's R, Python, other digital humanities tools. We can argue that we've eliminated barriers specific to web archives, and then we also have power users who use the toolkit directly and are comfortable managing computational infrastructure themselves. So our ongoing efforts is to A, provide training to increase the number of power users, empower our scholars to continue the accumulation of experience and comfort so they can use things like the toolkit directly, and then also diversify those derivatives. What extra derivatives can we make? What about a package of image files? What about a package of PDFs, PowerPoints, etc.? And trying to find the right balance between the resources that it takes to produce these derivatives and the scholarly demand for them. So, to conclude, the Archives Unleashed project has made substantial progress, but there's still a long road ahead. Broadening scholarly access is an ongoing process, and we look forward to working with many of you in the JCDL community over the Archives Unleashed project in the years to come. So, on that point, I'll say thank you. I'll thank you to our fundings and look forward to the discussion and questions that will follow. Thank you.